Greetings. Last week we learned that a mole is a portion of a chemical. So this right here would be a portion of water, and this would be a portion of copper sulfate. There's the same number of particles of water particles and copper sulfate particles in here. It's just that copper sulfate particles are a lot bigger than water particles. But chemicals interact with each other according to portions. So, for example, this here is iron 3 oxide, yeah? And you can see that it decomposes to form iron and molecular oxygen. So if we were asked something like this, in the following reaction, how many moles of iron are produced if 8 moles of iron 3 oxide are decomposed? Now we need to make sure that before we start the equation is balanced before we begin. So I'm going to switch from a pen to a pencil because whenever I balance equations, I like to use a pencil because I have to do some erasing sometimes. So how many irons are there right here? There's 2. And over here, there's only 1. So I can't put a little 2 right here because iron's not a Brinkelhofer. Iron does not come in diatomic molecules. There's no such thing as Fe2. But what there is such a thing is 2 portions of iron, like that. So now we have 2 irons on the left, 2 irons on the right. Over here we've got 3 oxygens on the left and 2 oxygens on the right. So the least common multiple of 3 and 2 is 6. So over here we're going to put a 3 because 3 times 2 is 6. And over here we're going to put a 2 because 2 times 3 is 6. And now we've got the same number of oxygens on both sides. Now our irons are messed up though because we got 4 irons here and we've got 2 irons here. So I'm going to erase this 2 and I'm going to put a 4 in there like that. So now if we check, we've got 4 irons here, 4 irons here. We've got 6 oxygens here. We've got 6 oxygens here. So this equation's balanced. So now we can begin. So the way the problem works is we're starting with 8 moles of iron 3 oxide. So we're going to start with 8 moles of the iron 3 oxide, and it's asking us how many moles of iron would be produced if that iron oxide was decomposed. So we're wondering how many moles of the iron are going to be produced, yeah? So what we're going to do is we're going to start with the number that we're trying to convert, which would be 8 moles, and we're writing units, and we're also going to write the chemical, iron 3 oxide. 8 moles of iron 3 oxide. And we're trying to figure out how many moles of iron are produced. How many moles of iron are produced. So my answer is going to be moles of iron. And this is where a story comes in. Long ago, there was a mischievous magician who was able to change things from one into another. That magician could change this paperclip into gold if she wanted to. Well, there was a more powerful magician that didn't have that power, and he tried to get her to make him a bunch of jewels, and she refused. So that powerful magician, who was not very nice, turned our transformer into a mole. Yeah? Transformed our transformer. Well, every time that mole dug a hole in the ground and an animal crawled into it, that animal would turn into a new kind of animal. So that hole created by a mole was transformative. And that's what this is going to be right here. This is going to be our mole hole. So the way the mole hole works is a chemical goes underground, So it goes underground in this case as iron oxide, and it comes up above the ground as a different chemical, in this case iron. So once again, the chemical starts being iron oxide, and it's just the math, but the math stops with what our answer is going to be, which is iron. So we're starting with iron oxide and we're finishing with iron. All we need to know is the relationship between iron and iron oxide. Moles of iron and moles of iron oxide. So in order to find that information, we're going to look at the balanced chemical equation here. It looks like we got 2 moles of iron oxide for every 4 moles of iron. So 4 moles of iron and 2 moles of iron oxide. Iron oxide, 2. Iron, 4. Yeah? Now all we have to do is 8 times 4 divided by 2. Because as you can see, I've got moles of iron oxide on top and moles of iron oxide on the bottom. So those are going to cancel out, and I'm going to be left with moles of iron, which is what I want my answer to be. So 8 times 4 divided by 2. I'm going to get out my calculator because I'm feeling a little crusty right now. 8 times 4 divided by 2 equals 16. So it looks like if we started with 8 moles of iron oxide, we'd end up with 16 moles of iron. Yeah? And that makes sense because it's a 2 to 4 ratio. So if I start off with 2 moles of this, I end up with 4 moles of that. If I start out with 8 moles of this, I end up with 16 moles of that. And these are nice clean numbers, but as we go, we're going to start to use numbers that are less clean. I showed you guys the answers right here, so you can check your answer, but don't just write it. Make sure you calculate it and see that your calculation comes out the same as the answer I wrote here. Follow these instructions right here, and you're going to be sweet.